Good afternoon, everyone, and welcome along to the first of our spring series of climate webinars. My name is William Fleming, and I'm joined today by Harley Brown-Keech and Dr Mary McEvoy, and we're here to discuss the clean element of our new climate smart range of mixes to help reduce emissions. Germinal, we're celebrating 200 years this year. The building on the right there is where we started all those years ago. And for the last 150 years of that, we have been a specialist seed company. And in 1960, we moved into GB. As a family-owned business, while we celebrate our heritage, we are always looking forward. And with that in mind, that is why we have designed our new range of climate smart mixes to try and help meet the challenges of today and tomorrow. We believe that science and the detailed trials that we carry out on field and in field scale help us to supply grass and legume mixes that will help farms meet the climate challenges that they face, both at a practical farm level and also from the legislation that's coming down from governments and also pressure from our end users. In 1986, the company formed a partnership with Iber's, and that resulted in the high sugar grasses, one of the first innovations to the market and which we are building upon now. In 2021, we took the next step and employed 15 of the breeders and technicians from Aber. They are still currently embedded at Aber, but they work solely for us here in Germinal. We feel that this puts us in a very strong position with a more direct input into the breeding and help us to react quicker, if you can react quickly in a breeding programme, to the changes that we see. As a result of these changes, our Germinal Horizon staff accounts for 20% of our team, and they're working across our 3 Horizon research facilities at Aber, in Wiltshire and in New Zealand. I would now just like to ask Harley to take over control of the screen, and we'll move on with the rest of the presentation.
Good afternoon, everyone. I'm going to be setting the scene for our Climate Smart Clean range and why we at Germinal think this is a crucial element to the sustainability jigsaw, alongside how we can all play our part in that role and what farm benefits it can provide. I'm sure you've all seen the headlines. Climate change has dominated the headlines for the last 25 years or so, with an increasing focus and targets on each UK and Irish sector in the preceding decade. You will all see and hear several targets and figures banded around the subject of climate change. The slides I'm going to work through now are all relevant to the agricultural sector. Many of you may have or are in talks surrounding emissions reductions targets with your milk buyers or meat processors. We will be interested to hear what the targets are looking like, and if anyone would be willing to share those in the group chat or Q&A function, it'd be great to see the industry at ground level. Unfortunately, much of the blame for climate change is our fault. There are too many of us. It took 200,000 years to reach a population of 1 billion, but then only 200 years to reach 7 billion. This rate increase has slowed, but it is not in decline. The United Nations predictions for the world's population is more than 3 times larger than it was in the mid-20th century. The global human population reached 8 billion in mid-November 2023, from an estimated 2.5 billion in 1950, adding 1 billion people since 2010 and 2 billion people since 1998. The world's population is expected to increase by nearly 2 billion people in the next 30 years, from the current 8 billion to 9.7 billion in 2050, and could peak at nearly 10.4 billion in the mid-2080s. It is stated that every person in the UK is emitting around 12.7 tonnes of CO2 equivalent per year. To put this into context, it is the equivalent to leaving your household heating on for 80 days solid or setting off in your car for a short 23,000-mile journey. The visualization I'm going to play presents monthly global temperature anomalies. The visualization is updated roughly 2 weeks after the end of each month. Temperature anomalies are deviations from a long-term global average. In this case, the period 1951 to 1980 is used to define the baseline for the anomaly. The past 9 years have been the warmest since modern record keeping began in the 1880s. In 2022, the Earth was about 1.1 degrees Celsius warmer than in the late 19th century average. The Paris Agreement of 2015 set out that it will substantially reduce global greenhouse gas emissions to limit the global temperature increase in this century to 2 degrees Celsius, while pursuing efforts to limit the increase even further to 1.5 degrees. As of today, there are 195 parties signed up to the agreement. Currently, global temperature is at a 1.3 increase within the 2 degrees target. The International Climate Change Committee suggests there is now less than a 5% chance of holding to the 2-degree target set in 2015. Currently, national determined contributions from the parties committed to the agreement would see a 2.6% decrease in greenhouse gas emissions overall. This is unfortunately, however, far short of the 43% needed to adhere to the 2-degree limit. Here we are looking at the progress in cutting UK greenhouse gas emissions. This slide is our biggest concern. If you take the big four, being energy, manufacturing, transport, and agriculture, energy supply and the industrial processes may be higher, but they are showing significant falls due to significant change through solar, nuclear, coal reductions, or wind generation. Agriculture is reducing and trending in a leveling off fashion over the timescale period on the graph. We aren't seeing any further improvements than we have made and need to continue improving. We are most concerned about this slide, as if you note the transport line in red. This hasn't made any improvements over the timeframe of the graph either, and this has led to government intervention in the banning of diesel and petrol cars by 2035. We could face changes being imposed on UK and Irish agriculture over time if we stagnate further or become the greatest emissions output due to other industries improving over time. What do all these greenhouse gases do, and what are their impacts on the Earth? For each greenhouse gas, a global warming potential has been calculated to reflect how long it remains in the atmosphere, on average, and how strongly it absorbs energy. The global warming potential of greenhouse gases is a measure of how much heat each gas traps in the atmosphere relative to carbon dioxide. Your primary sources of carbon dioxide are from burning fossil fuels, oil, coal, natural gas, deforestation, and soil degradation add CO2 to the atmosphere. Methane sources include production and transport of fossil fuels, organic waste in landfills, and in Ireland, the largest source of methane is from livestock and agricultural activities. Methane doesn't persist long in the atmosphere, but the problem is its impact is 25 times greater than carbon dioxide over a 100-year period. Nitrous oxide remains in the atmosphere for around 114 years and has a global warming potential which is 298 times greater than CO2 over that 100-year timescale. Nitrous oxide is emitted during the combustion of fossil fuels, industrial activities, and in agriculture, mainly through nitrogen fertilizer and livestock waste being two primary sources. Overall, agriculture is responsible for 98% of the nitrous oxide emissions in Ireland as well. The fluorinated gases at the bottom there are synthetic, entirely man-made, and nearly exclusively result from human activities, such as manufacturing and industrial processes. These gases can be found in different products, such as fridges or aerosol cans. While they are not ozone depleting, they have a very long atmospheric lifetime, and their global warming potential is also very high, fostering the need for sustainable recycling and production of these elements to limit the overall levels.
Before you move on from that, Harley, just a quick question has come in. Could you explain the global warming potential again, please? It wasn't clear to one of the
absolutely.
listeners.
So greenhouse gas has an equivalent global warming potential, and that has been calculated to reflect how long it remains in the atmosphere, on average overall, and how strongly it absorbs energy. And a global warming potential, again, of the greenhouse gas is a measure of how much heat each gas traps in the atmosphere relative to carbon dioxide. Thank you.
Thank you.
So I'm going to begin looking at the UK and Ireland as a whole for their greenhouse gas emissions, then moving on to sectors and finally contributors within the agricultural sector specifically. Carbon dioxide emissions in Ireland are the greatest contributor, and from the previous slide we note that is primarily from burning fossil fuels. oil, coal, and natural gas, alongside deforestation and soil degradation, followed by methane contribution to greenhouse gas emissions in Ireland, and this is primarily due to the large population of cattle. In 2023, it is estimated that emissions of methane were 16 kilotons of CO2 equivalent, indicating a decrease of 4% on the 1990 level. Emissions of methane increased progressively from 1990, reaching a peak in 1998, reflecting an increase in livestock numbers and therefore increased emissions from source categories, being enteric fermentation and manure management. Between 1998 and 2011, methane emissions then decreased because of falling livestock numbers from reforms of the Common Agricultural Policy, or CAP. The main contributor to methane trend has been the agricultural sector, and in 2023, this accounted for 94% of the total methane emissions. Lastly, nitrous oxide emissions decreased by 22% from their 1990 level. Like methane, emissions of nitrous oxide increased during the 1990s to a peak in 1998, again reflecting increased use of synthetic fertilizers and increased amounts of animal manures associated with those increasing animal numbers over that period. Emissions of nitrous oxide subsequently showed a downward trend following reductions in synthetic fertilizer use and organic nitrogen applications on land because of those CAP reform and animal numbers. However, in 6 of the last 10 years of the greenhouse gas inventory, nitrous oxide emissions increased as the dairy sector again expanded and nitrogen fertilizer use increased. Unfortunately, the largest contributor to the trend is the agricultural sector, with a 92% share of the total nitrous oxide emissions in 2023. This reflects an increase from 81% in 1990. We have looked on the previous slide at the greenhouse gas emissions. Now we are viewing sector contributions to the overall totals. For Ireland, we see that agriculture is contributing 38% of the total emissions. The next biggest contributor is transport. Irish agriculture has seen potential impacts around the reduction of cattle numbers and quotas being removed. But on the flip side to this, some positives are seen in using increased clover content in grass lays, both red and white clover, alongside herb contents to push homegrown protein. I do, though, believe it's important here to note that Irish agriculture is contributing a value to the Irish GDP of 0.88% in 2023, equated to circa 24 billion, compared with the UK GDP sitting at 0.56%, which is only circa 13.7 billion. So again, if you cast back to the UK emissions chart with agriculture stagnating, alongside agriculture being the largest contributor to greenhouse gas emissions in Ireland, things do need to progress in a positive manner, balancing food production, food security, profitability, and sustainability on farms. Here, we are looking at the breakdown of greenhouse gas emissions within the agricultural industry in Ireland. Enteric fermentation is the leading contributor, which is a natural digestive process in ruminant animals where microorganisms in the digestive tract break down food, producing methane as a byproduct. Nitrous oxide from fertilizer application and soil cultivation is in second place, produced as part of the natural farming system with inputs versus outputs. Third place is a combination of methane and nitrous oxide from management, storage, and spreading of organic matter. These all directly relate to the number of ruminant animals in the country. Hopping over the water, I'm now going to look at the UK emissions as a whole. Unfortunately, the methodology and reporting statistics for the two countries don't align totally. So if I appear to be talking in riddles, please bear with me. I must say at this point, the Irish data produced is much more user-friendly and easily obtainable. The UK reporting methodology used from 1990 to 2023 has changed in 2023, with only some provisional data being published, and in the interest of presenting like for like with the Irish data, information from 2022 has been used. The UK is pushing a higher carbon dioxide emissions value compared to Ireland at over 19% higher. However, the methane and nitrous oxide emissions are reduced by nearly 50% in both cases. Here we are viewing the UK greenhouse gas emissions output per sector, noting here agriculture contribution being in fourth place behind transport, infrastructure and industry. The UK also has a fewer number of cattle in 2023, circa 2 million less than Ireland. However, due to the weighting of other industries in the respective countries, the overall emissions of the sector is greater in Ireland, as I mentioned earlier. Agriculture in the UK is responsible for 46 million tonnes of CO2 equivalent. And to put that into context, it's about the same weight as 150 Empire State Buildings. DEFRA states that it is estimated that agriculture is responsible for 47% of the UK's methane emissions, 68% of the UK's nitrous oxide emissions, and just 2% of the UK's carbon dioxide emissions. Now we begin to pick apart agriculture's contribution to greenhouse gases as a sector in the UK. Carbon dioxide is greater than in Ireland, predominantly due to arable versus grassland production in the UK and the associated number of operations. Again, nitrous oxide emissions in the UK are higher than Ireland, which is comparable when we compare land use figures with applied fertiliser totals across the arable and livestock sectors. The UK applied circa 871,000 tonnes of nitrogen in 2022-23 season, compared to Ireland applying 281,000 tonnes of nitrogen in the 23 season. With the emissions cost of producing a tonne of nitrogen sitting around 2.6 tonnes of carbon dioxide equivalent, 1.7 tonnes of carbon dioxide equivalent for phosphate, and 0.6 of a tonne of carbon dioxide equivalent for potassium, you can understand why the figures can mount up quite quickly. Methane equated to 56% of the output from agriculture in the UK, again, predominantly from livestock and manure management. Excuse me. To help reduce overall emissions targets of UK and Irish agriculture, the respective governments have introduced a series of measures to aid this process. The targets are different for both parties due to the varying outputs of the sector. Both targets are listed here on the slide. The Irish have specific targets around nitrogen application, reduction, and urea inhibitors, alongside a push towards organic agriculture. Irish agriculture currently sits around 225,000 hectares, and the UK is sitting around 498,000 hectares. The Irish figure is a positive step to the target, with a further 1,000 holdings joining in the previous year, now sitting at 5% of the 10% total target as per the Climate Action Plan. The overall use of technology can help to meet these targets, from precision applications, overall recycling of waste material entering the farm, such as plastic containers, pushing daily live weight gain of stock to shorten finishing times, or using low emission spreading systems to minimise emissions, particularly around ammonia. The UK has implemented common actions across the devolved governments around energy efficiency, recycling, and nitrogen application. Progress has already been made in this space. DEFRA emissions and production statistics suggest that since 1990, we are producing a litre of milk with 17% fewer greenhouse gas emissions. Efficiency gains in dairy farming mean that we are now producing 9% more milk than in the year 2000, with over 24% fewer cows. Improving and protecting soil health requires sustainable management. The UK has set a target for at least 70% of farms and farmland to be in environmental land management schemes, and to have at least 40% of England's agricultural soils under sustainable management through ELMS by 2028, increasing this up to 60% by 2030. And finally, from me, unfortunately, we don't have a silver bullet for farmers on the overall reductions in greenhouse gas emissions, but can help in the benefits of grassland in the farming system. To help achieve net zero in agriculture in relation to grassland, we can look to action the points on the slide. By capturing more atmospheric nitrogen, we're reducing the need for artificial nitrogen on grassland, and we have seen the emissions potential and costs from the production of fertiliser. Using red clover and producing homegrown protein, minimising the production and haulage of blends down the farm drive, pushing carbon capture with multi-species swords and the deep taproots available with certain herbs and legumes, utilising Aber HSG material in all swords on the farm, which Mary will discuss further in her presentation. With grassland having the ability to fix between 1.5 and 4 tonnes per hectare per year of carbon, you have the ability as grassland managers to help reduce our overall emissions. From a plant perspective, we want to focus on maintaining the yield, quality, and productivity of our grasses, but with the added benefit of reducing the environmental impact when they are adapted at farm level. With Germinal's leading forage breeding programme at IBERS, we are pushing the boundaries of forage production, not only through the traditional perennial ryegrass, but with novel products such as our double root. Thank you.
Thanks very much. Good afternoon and welcome everyone. So I'm just going to give a quick run through on what we can do in livestock grazing systems to reduce the emissions associated with grass-based production systems. I also want to introduce our new Climate Smart range of grass and forage seed mixtures. These are now available both in Ireland and the UK to help farmers maintain production and performance, which is going to be critical for sustainable farm systems going forward, but also allowing us to address the key climate-related issues that we see at farm level. And I'll discuss them towards the end of the presentation. So just as Harley has said, just to recap, those key greenhouse gas emissions which are relevant to agriculture are methane, nitrous oxide and carbon dioxide. As it stands, we have no silver bullet. It'll have to be a combination of actions which we implement at farm level, which will allow us to reduce overall emissions from agriculture. Firstly, just a quick look at methane. Methane is the second most important greenhouse gas globally. And as Harley has said, it's produced as a result of enteric fermentation, which essentially is a natural process. Ruminant livestock, as you're all aware, have a unique ability to convert grass into high protein dairy, milk and meat production, which is suitable for human consumption. Enteric fermentation is a byproduct of the natural digestive process of ruminants. It occurs when forage is consumed by the ruminant livestock and digested by microbes in the rumen. One group of rumen microbes, which are known as methanogens, are responsible for production of methane, which is a wasteful end product of ruminal feed digestion, but it is an entirely natural process. We also see methane produced as a result of the decomposition of manure in anaerobic conditions. So what are the solutions we can implement at farm level to reduce methane emissions associated with livestock production? And it's fair to say that there's a number of these solutions that I'm going to talk about through my presentation here today that are already being implemented, and some are still in the early stages of research as well. But there are plenty of things that we can do and plenty of things that farmers are already doing. So we can supplement animals' diet to reduce methane emissions. And we do know there are certain supplements which have the potential to significantly reduce methane emissions, but these are showing more success in indoor feed systems where we can feed a consistent amount of these supplements right throughout the day. Some seaweeds have shown reductions of up to 80% in terms of total methane output by indoor fed beef cattle. We know by the addition of fats and other lipids to animal feed. These fats contain high proportions of polyunsaturated fatty acids, and these have also been proven to reduce and significantly reduce methane emissions across numerous research projects at this stage. Bovaer, which is already available on the market and has had a lot of press coverage in the UK in recent months, has been shown to reduce methane emissions by about 30%. And this is already approved for use in the EU dairy industry, and there's an application in as well for its use in the beef industry. So there are certain things available and certain things in progress in terms of early stages of research. The biggest challenge with these dietary supplementation is they do show good effectiveness in indoor feed systems, but they can be much more challenging to see the same level of success in grazing systems because animals are essentially out of pasture during the day and only return into the parlour to receive the supplement in the morning and again in the evening. We do know that we can select and breed animals which emit less methane. This is a long-term strategy, but recent research from Chagas and ICBF have highlighted a 30% difference in daily methane emissions between beef cattle of similar breed, age, and offered a similar diet. If we improve animal health, a healthy animal will be more productive during its lifetime. So essentially it would have a dilution effect in terms of the output of the animal versus the methane produced by that animal. So optimizing animal health, which can increase milk yield, increase live weight gain, and reducing the age to slaughter has the potential to reduce methane over the animal's lifetime. And in terms of something we're already doing, we can improve our grassland management on our farms. A reduction in sward digestibility, which is associated with an increase in the fibre content of the grass, leads to a notable increase in enteric methane emissions, as it promotes an abundance of ruminant microbes which are associated with methane production. Both good grazing management and the incorporation of more digestible forages, and clovers in particular, within the grazing system have the potential to promote greater average daily live weight gains, improve milk performance, and therefore see an improvement in overall animal performance and as a consequence, a reduction in the methane emitted over the lifetime of the animal. Moving on to nitrous oxide. Agriculture, as Harley has said, accounts for over 90% of nitrous oxide emissions in Ireland. The main causes of nitrous oxide emissions are associated with the application of synthetic fertilisers to pasture, which accounts for almost 40% of our total nitrous oxide emissions. The deposition of animal excreta during grazing accounts for about 23% of our total nitrous oxide emissions. And the final 14% is associated with manure management in terms of slurry storage and spreading. So what are the solutions to reducing nitrous oxide emissions from agriculture? It's well researched and documented at this stage that if by correcting soil pH through the application of lime to our soils, we'll have an optimum benefit in terms of improving plant growth, but also improves soil structure and increases water infiltration rates. There's an economic and an environmental benefit to doing this. Where the soil pH is corrected, we do know that the soil then has the potential to release up to 70 kilos of nitrogen, which is free nitrogen essentially that's there in the soil, but is released at the optimum soil pH. And other nutrients within the soil also become more available. So we see a benefit in terms of increased pasture performance without the addition of additional fertilizers. Protected urea, which is urea that has been treated with a urease inhibitor, prevents the conversion of urea to ammonium. This is widely recognised as bringing beneficial effects in terms of reducing the amount of nitrous oxide emissions being emitted, while at the same time maintaining yield output of the sward. If we establish more clover in our swards, it will reduce our dependency on artificial nitrogen. And I suppose there's been a strong move towards increasing the clover content in our swards over the last couple of years, and we saw a significant uptake in clover when prices of fertiliser increased dramatically about 3 years ago. So farmers are responding, they are adopting more clover into their swards. They're trying to reduce the nitrogen that they're applying to those swards in order to support clover growth. And this is going to have a positive impact in terms of reducing overall nitrous oxide emissions. And we also have Aber High Sugar Grasses. So a lot of you are probably already familiar with the Aber High Sugar Grasses, especially the UK audience who is tuned in today. In Ireland, although most of you will be familiar with the Aber brand name and the Aber grasses that are available on the market, in Ireland we have probably, for the most part to date, focused on the quality benefits of these grasses. But there is an additional benefit to them as well. So just as a brief background and to quickly explain what they're about. So the high sugar grasses essentially do exactly what they say in the tin. They're selected within our breeding programme over many generations and have demonstrated an increased sugar content over their conventional counterparts. This sugar is non-structural water-soluble carbohydrates, or WSCs, and they act as a storage carbohydrate in grasses. We do know these water-soluble carbohydrates are energy dense, and where we see an increase or a high concentration of water-soluble carbohydrates, that's generally also associated with an increase or a high level of dry matter digestibility or grazing D value. And this is quite obvious across both the Irish and UK recommended lists, where the Aber material generally is the higher performing material from a quality perspective as well. But in addition to the improvements in digestibility of the grass, water-soluble carbohydrates also provide an immediate energy source for rumen microbes. So when we look at a grazing animal, there's generally surplus protein and a lack of energy going into the diet. Where we increase that energy going into the diet through the addition of sugars or water-soluble carbohydrates, we can increase the microbial protein yield, we can increase the milk yield and animal performance of the animals grazing these swards, and there's research has shown up to 6% increase in milk yield with animals grazing high sugar grasses compared to conventional grasses. And we can also reduce the waste nitrogen associated with grazing these swards as well. So just to put this into a diagram form, maybe, which helps explain it a little bit clearer. And if we look at the red text here, or the red figures are essentially conventional grasses. When an animal consumes a conventional grass, which is not high in sugar, only about 25% of the protein consumed is utilised by the animal, and the rest of that is excreted as surplus nitrogen in both dung and urine. So you can see here for the animal grazing the conventional sward, 23% or close on 25% is being directed into milk, and the balance has been excreted, with 42% being excreted in faeces and the additional 35% being excreted in urine. If we can increase the energy content or the energy density of the diet going into the animal, those microbes that are in the rumen have more energy, so they can better utilize the protein that's already available there in the rumen. So in this case, what we see is those microbes can convert more of that protein into a live or an animal available protein. So the animal can convert more of the protein into milk or meat, with less nitrogen being excreted as surplus through the feces and urine. And if less has been excreted in terms of feces and urine, we see a subsequent reduction in terms of the nitrous oxide emissions and also the ammonia emissions associated with grazing livestock.
Mary, before you move on, a quick someone's asking, are the milk buyers actively asking for these grasses and mixtures when it's in relation to carbon footprinting?
There is a focus in terms of here in Ireland in particular, William, in terms of, I suppose, the milk buyers are providing a sustainability bonus to farmers, but that's generally offered across a range of measures, and essentially farmers can pick from a suite of measures, and that might be incorporating more clover into the swards, which we know will improve the digestibility of the sward, but also reduce the dependency on fertilizer nitrogen, move towards fertilizer protected urea as a fertilizer source, and there's other measures within most of those sustainability programs to support farmers to reduce their emissions. There's not per se at the moment a push to adopt high sugar grasses across farms here in Ireland. Do you want to comment yourself on the English scenario?
I think on our side of the water here, Mary, it's very similar. It's all about sustainability and choosing from the suite of options. But one of the big ones is reducing the carbon footprint of CO2 equivalent per litre of milk produced. And what you've just said there, the high sugar grasses fit really well into that. But again, it's very similar to the situation that you have on your side at the moment.
Yeah, that's fair to say. And look, I suppose the other thing that's pretty worth saying as well, the high sugar grasses, you're not going to see the benefit if it's just one field. This is more beneficial if animals are on the high sugar grasses for the majority of their time when they're out of the grass, to get an effect over time rather than just a once-off effect as well. In terms of carbon dioxide, approximately 2/3 of the total increase in atmospheric carbon dioxide is derived from fossil fuel combustion, as Harley has already said. The other 1/3 is a result of land use change and a conversion of natural vegetation to managed lands. Farms will also emit carbon dioxide from activities such as ploughing, sowing and chemical treatments, and lime and urea application are the main sources of carbon dioxide that we see from soil. What are the solutions to reducing carbon dioxide emissions from agriculture? So reduced tillage. We do know that ploughing can result in a massive leak of carbon out of the system over a very short period of time. And in Ireland, farms and irrigation can no longer plough after the 31st of May. So looking at reducing soil disturbance to reduce carbon dioxide losses. And I think, we're seeing this across the board as well. Farmers are probably moving more towards disc and one pass or direct drilling when they're reseeding compared to ploughing, unless there's a very uneven field and they need to level a field. Liming, and although I have said it's a source of carbon dioxide, I think it's really important to remember that the benefit of liming far outweighs the loss in carbon dioxide that we see at farm level. By correcting our soil pH, up to 70 kilos of nitrogen can be released into the soil, which I've already said. We reduce the need for artificial nitrogen, where we have a soil at the optimum pH level. And as a result, we'll reduce our nitrous oxide emissions as well. Where pH is optimized, we see a benefit in terms of the nutrient availability and pasture growth. Optimizing the pH of our soils needs to be always the target. We need to make sure, I suppose, lime is one of the cheapest fertilizers that's available out there. It makes your other nutrients much more available to the plant as well. So we need to always focus on optimizing the lime status and the pH status of our soils. Typically grassland soils, we're looking at about 6.2 to 6.5. For grass clover swards, we're looking at 6.5 to 7 as our optimum pH level. Soil carbon sequestration is an important means of removing carbon dioxide from the air and storing it in the soil. And this also improves a number of aspects of soil health. So carbon stored in soils is often called soil organic carbon, and it's of benefit to soils. It improves their workability, it improves their water holding capacity, which is really important if we're going into dry spells and getting these increased incidents of drought during the summers. And it also increases the productivity of swards. Research has shown that grasslands are generally considered a carbon sink, with values for carbon sequestration ranging from about 1.5 to 4 tonnes of carbon dioxide per hectare per year stored within grassland soils. There are many ways where we can continue to improve the carbon sequestration of our soils through improving soil fertility, the establishment of grass clover and multi-species swards. So, you know, having more diverse swards compared to grass, you know, a monoculture of grass, for example, planting extra hedgerows on farm. Additional woodland and forests are also going to be a major store of carbon from the atmosphere. And, you know, there is a focus at the moment as well in terms of and a look towards restoring drained wetland as an example to reduce our carbon dioxide emissions. Just finally, I want to have a quick look at ammonia. Even though it's not actually a greenhouse gas, it can indirectly contribute to greenhouse gas emissions. So this happens when ammonia volatilizes from soil, moves through the air and gets redeposited elsewhere. This redeposited ammonia can then act as a substrate for emissions of nitrous oxide. And in Ireland, agriculture is responsible for 99% of our overall ammonia emissions. So, you know, there is a pressure at farm level to reduce our emissions of ammonia. So the main sources of ammonia out on farm are manure management, including housing and storage, which accounts for almost 50% of our ammonia emissions. Spreading of slurry accounts for about 30%. Animal grazing will also reduce release ammonia, and the use of synthetic fertilizers is the fourth main source. So what are the solutions to reducing ammonia at farm? We've seen a strong move in recent years towards low emission slurry spreading, and you know, low emission slurry spreading can reduce ammonia emissions by half compared to a splash plate, and it also improves the nutrient value of the slurry. So it's a benefit from an environmental perspective, but also a benefit to the farmer. Protected urea can reduce ammonia emissions by over 70% compared to CAN or standard urea. Incorporating more clover into our swards and being less dependent on artificial nitrogen will also have a significant impact here. As I mentioned already, with Aber High Sugar Grasses, as we see less nitrogen being emitted by the animal in urine or in dung, we see a reduction in both nitrous oxide and ammonia emissions when animals are grazing Aber High Sugar Grasses. Because so much of the ammonia is associated with the housing and storage of slurry, if we can extend our grazing season, it'll reduce ammonia losses from agriculture as well. And slurry additives are another means that can be considered in terms of addressing this issue. I just want to briefly touch on the role of plant breeding, and in terms of, you know, what plant breeding can offer. We're aware of the Aber High Sugar Grasses, which are available already. We've talked about clover, we've touched on multi-species, but what else is happening in the world of plant breeding that can help us address some of the challenges agriculture is facing? So further increasing plant digestibility above and beyond where we are at the moment has the potential to improve animal performance and also reduce methane emissions from grazing animals. We're also within our breeding program looking at the grass lipid content. So forage contains lipids which are essentially predominantly polyunsaturated fatty acids, and these are considered good fats, and they're better known as your omega-3s, and these have a positive impact in terms of human health. From an animal production perspective, increasing the polyunsaturated fatty acid supply has been shown to improve animal fertility and also to result in a positive effect in terms of meat quality. So we get a longer shelf life and a more desirable colour, which is going to be of interest, I suppose, to the meat plants. There is also evidence of increasing lipid content and an associated reduction in methane emissions where there's a high proportion of polyunsaturated fatty acids in the diet. And this has been identified both in feed additives, so feeding lipids in our feed system, but it is something that we believe we can also achieve through plant breeding. Fatty acid content of grass is somewhere around between 2 and 5%, the average of probably 3 to 4%, and there is scope to increase this significantly through grass breeding. We're looking at breeding and selecting more persistent and grazing tolerant legumes within our breeding program. We already have double root, which is a cross between a Caucasian and a conventional white clover available on the market. The variety is Everlasting. And this has rhizomes as well as your standard stolons. So these rhizomes give increased grazing tolerance to the variety, as well as improving the drought resistance or the drought tolerance and the cold tolerance of this variety. So we've seen this variety perform in minus 30 degrees, so it can really deal with the extremes the climate might throw at it. Hopefully that won't be something we ever see in Ireland or UK in the near future, but it just goes to show the potential that we can achieve through plant breeding. Red Runner is a clover which is in development at the moment, and essentially this is a red clover which also has stolons, and obviously we normally associate stolons with white clovers. This is a real game changer. The benefit here is we'll have polyphenol oxidase, which is present in red clover, and this is an enzyme which, when under cellular damage produces quinones. These bind to the proteins and protect the proteins so they pass through the rumen undegraded, so the animal gets better utilization of the protein that it has consumed. And the other big benefit here, it reduces the production of greenhouse gases as well, and methane in particular. Conventional red clovers are traditionally used in silage systems. They tend not to be very persistent when grazed. But we have this this Red Runner variety under intensive sheep grazing, and it's shown really, really good tolerance and persistency under that intensive level of grazing. So it'll be essentially a grazable red clover with lower methane emissions potential going forward. And we're really excited about getting that to market in a couple of years' time. We're also looking at bird's foot trefoils. Essentially, these are legumes which have a high proportion of condensed tannins. These tannins bring several benefits. They inhibit or stop methanogenesis, which is methane production in the rumen, and can reduce methane production by up to 32%, which is quite significant. They also have the potential to reduce bloat, and they have an antihelmintic effect, so reduce worm burden in animals. So from an animal health perspective, it's a very positive thing. The current varieties of bird's foot trefoil that we have or that are available on the market tend not to survive in what we would consider productive or intensive grassland lays, and they don't do very well under grassland either. We are developing a new variety with the objective to achieve both environmental and performance benefits, so it'll tolerate intensive grazing and suit grazing systems going forward. I also just want to quickly mention New Leg, which is a project which has been funded to the tune of 3.3 million by DEFRA in the UK, and Germany is leading this project with 10 other partners. And the aim of this project is to reduce the dependency of grass-based systems on artificial nitrogen. So we want to improve the efficiency of food production and reduce greenhouse gas emissions. The project is particularly focused on improving the relationship between Rhizobia bacteria and the clover plant. And by using more efficient strains of Rhizobia, we have the ability to fix up to 300 kilos of nitrogen compared to around 100 to 150 kilos of nitrogen, which is what we're currently fixing with white clovers today. So potentially to significantly reduce our dependency on fertilizer nitrogen in grazing systems going forward. Now, I just want to briefly touch on a new product range which Germany have brought to market this year. This is available across both Ireland and the UK, and it's our Climate Smart range. Our aim in introducing these new mixtures is to create a unique set of products that help us all discuss grassland production in terms of the business needs of farmers. So we're very much focused on the productivity and performance of these grass seed mixtures. We also want to highlight and address how choosing the right mixture and having it in the right place can help farmers address some of the key climate challenges that they face. So essentially, it's about marrying productive performance and sustainability in a grass-based system. These mixtures are built on Aber High Sugar Grasses. I've discussed them already. A lot of you are probably already familiar with them and using them in many of the mixtures you're implementing on your own farms. But we do know with the Aber High Sugar Grasses, we can see an improvement in performance, plus the benefit in terms of reducing methane or reducing nitrous oxide and ammonia emissions, and delivering high quality milk and meat production. So I suppose essentially it's a win-win situation. Within this range, there are 5 different categories across the Climate Smart range, and they are designed to help farmers assess which mixture will work best for their particular business and environmental priorities. So we have the Climate Smart Clean range, which I'm going to talk about today, which is focused on emissions reduction. We also have a category looking at soil support, so building soil health, plant resilience to allow us better tolerate extremes in the weather, which we've all seen in recent years, improved nutrient efficiency, and we also have a category there which meets the government-led environmental schemes. In terms of the Climate Smart Clean, and for the purpose of today, and because we're limited by time, I just want to give a quick overview on this range in particular. I won't go into any of the other 4. But within this category across both Ireland and UK, there are short, medium and long-term silage options, and also grazing mixtures which will suit specific requirements. The full details on the mixtures can be found on the German website. But as I've said already, they're formulated with the best performing Aber High Sugar Grasses, where we know the animals can digest the protein from those grasses more efficiently because we have more energy gone into the rumen with these grasses. And we also have very high digestibility grasses within these. So we see an improvement in animal performance. And essentially, they will support high productivity and performance at farm level, while also helping us to address the challenge of reducing emissions that we need to achieve at farm level. So just to summarise, as I've said, methane and nitrous oxide, followed by carbon dioxide, are the main greenhouse gases associated with agriculture. There are a number of tools which are already available, which allow us to improve our efficiencies and adapt best practice, can help us on the journey towards reduced emissions. So we have seen a wide uptake of low emission slurry spreading, the adoption of protected urea, improvement in soil health and fertility, and liming in particular can go a long way in terms of helping us address some of the challenges that we face. Incorporation of more clover into our grazing swards, the adoption of high sugar grasses, and improved grassland management are some of the key technologies that we have available in grass-based systems to help us as we move on this journey to reduce agricultural greenhouse gas emissions. I want to thank you for your time. If you have any questions, more than happy to take them now.
Thank you, Mary. Just give you a minute to get your breath back after that, and then I'll share the results of the poll, which we took place in there. And there we see that the big driver for reducing emissions is improving our soil fertility. And another big one there is liming, which is great to see that people are really getting to grips with the idea of improving our soil health as the driver for everything that we're doing. A couple of quick questions for Harley and Mary. And the first one is to Harley. In one of your slides, Harley, you were saying about the 22% reduction in emissions. What was the base year has been asked for that one?
The base year was from 1990, and a figure of 49 million tonnes is the starting figure baseline.
Right,
where they're working reduction from.
Thank you. A question here, I think specifically for Mary. It's from one of our Irish attendees. When selecting grasses through the Irish PPI list, is it adequate to select for quality and grazing utilisation, i.e. the star system, to achieve high sugar grasses? I think you'll know more about that than any of us, Mary.
Look, I think when we're formulating mixtures, we need to look across all traits, rather than focus on one trait or in particular. The Aber High Sugar Grasses are what are associated with increased water soluble carbohydrate content. So just because you have something that's performing well in terms of utilisation trait doesn't mean necessarily that it is an Aber High Sugar Grass. All the Aber High Sugar Grasses are prefixed by the name Aber, so that's one easy way of identifying them. But I mean, it's 100% when we're formulating mixtures, we need to look at performance of grass varieties in a blend across all traits rather than just focusing on one trait. But quality is hugely important, absolutely.
Right, thanks, Mary. I'll have one final question for the two of you. And it's particularly relevant when we saw the results of the poll with people focusing on liming and improving soil pH. What are your thoughts on prilled lime versus bulk?
So what I would say, I suppose, in terms of that is it depends. So it depends essentially on the current pH of the soil. And the prill lime will work quite effectively, quite quickly, but it's a lot more expensive. So bulk lime allows us to, spread more. Most farms have a reasonably high requirement across a lot of their area for 2 ton plus of lime. So it's more, I suppose, cost effective to go with bulk lime. A third of it will start to work immediately. A third will start work over a 6-month period, and a third will work over, an extended period of a year or beyond. So both have a role. The prill lime probably works very well in a reseeding scenario where maybe you're only doing one field, but the bulk lime, I think, is a no-brainer for a lot of farms when they have a requirement across a lot of the farm.
Yeah, I'd agree. And just to add to that, obviously the quality of the lime is important, in terms of the granule size, as Mary said. I think anything over sort of 2.5 millets, is an investment for your great grandchildren.
Thanks, Harley. I think I'll just add one quick comment on the lime before we draw everything to a close today. In my part of West Central Scotland, historically there was a lot of magnesium lime used, so we're ending up seeing problems with very high mag indexes in soils. So have your soils analysed and know what you need to make sure that you use the appropriate liming product in the appropriate rate. So thank you all very much, and have a good day.